Hello everyone, welcome to my seminar. First of all, thank you for watching my seminar. My name is Tejasvin Bhukya. I am from EE18 batch. As you can see from the title on my screen, my seminar is on history and evolution of image sensors. Let's get into this. Introduction. An image sensor An image sensor is a sensor that detects and conveys information used to form an image. It does so by conveying the variable attenuation of light waves into signals small bursts of current passes that conveys the information. The waves can be light or other electromagnetic radiation. Image sensors are used in electronic imaging devices for both analog and digital types, which includes digital cameras, camera modules, camera phones, optical mouse devices, medical imaging equipments, night vision equipments such as thermal imaging devices, radar, sonar, and others. As technology changes, electronic and digital imaging tends to replace the chemical and analog imaging. Now, this presentation will give a brief overview of history and evolution of image sensors from the early attempts at capturing image to current innovations in image sensor technology. Now let's get into the early attempts of image sensors. Early attempts of image sensors are nothing but cave paintings, drawings and sculptures to remember the history. Then we got pinhole cameras. A pinhole camera is a simple camera without a lens but with a tiny aperture, effectively a light-proof box with a small hole in one side. Light from a scene passes through the aperture and projects an inverted image on the opposite side of the box, which is known as camera obscura effect. Since the image size of image depends on both distance between object and pinhole. Let's move on to other discovery, that is camera obscura. Camera obscura is a darkened room with a small hole or lens at one side through which an image is projected onto a wall or table opposite the hole. Camera obscura can also refer to analogous constructions such as a box or tent in which the exterior image is projected inside. Camera obscuras with a lens in the opening have been used since the second half of the 16th century and became popular as aids for drawing and painting. This is the normal painting, this is the pinhole camera, and this is the camera obscura box device. Let's move on to other inventions. Daguerreotype. Daguerreotype is first practical photographic process. The process by Louis Daguerre. The process is a nothing but a silver-plated copper sheet is exposed to light and developed using mercury vapors to make an image. The daguerreotype invention was worldwide in 1839. There was almost completely superseded by 1860s with new and less expensive processes such as ambrotype that yields more readily viewable images. Then there has been few few group of photographers made a revival of this process in 20th century for making artistic use of early photographic processes. Basically, this process in history of image sensors demonstrate the possibility of capturing and preserving images using the technology. This is the great person daguerreotype and this was the first image. Let's move on to the next invention. Photographic film. A photographic film is a strip or sheet of transparent film based coated on one side with a gelatin emulsions containing microscopically small light-sensitive silver halide crystals. The size and other characteristics of the crystal determine the sensitivity, contrast, and resolution of the film. It was the earliest form of image capture in 19th century. It used to produce the negative images. Let's move on to next image. Vidicon tube. Vidicon tube was a first electronic image sensor was invented in 1950s. Vidicon tube is nothing but a storage type camera tube in which the charge density pattern is formed by the image seen radiation on a photoconductive surface, which is then scanned by a beam of low velocity electrons. This is nothing but a Vidicon tube, and this is the modern television cameras. Before invention of CCD or CMOS, Vidicon tube was used in television cameras, but nowadays CMOS image sensors are used in television cameras. Let's move on to next discovery. Charged coupled device. The invention of first image sensors with semiconductors was by George E. Smith and William S. Boyle in 1969. Now let us find how they invented CCD. The story of CCD. In late 1960s, William Boyle and George E. Smith at Bell Labs were researching MOS technology while working on semiconductor bubble memory. They realized that an electric charge was the analog of the magnetic bubble, that it could be stored on a tiny MOS capacitor, as it's fairly straightforward to fabricate a series of MOS capacitors in a row. They connected suitable voltage to them so that the charge could be stepped along from one to the next. This led to the invention of charged coupled device by Boyle and Smith in 1969. They convinced of the device of what they termed in the notebooks are charged bubble devices. Now we get a question: what is CCD? A charged coupled device, which is also known as CCD, is an integrated circuit containing an array of linked or coupled capacitors. Under the control of external circuit, each capacitor can transfer its electric charge to the neighboring capacitors. And the early application of CCD sensors are used in digital cameras, scanners, and video cameras, etc. These two great persons are George Smith and William S. Boyle, and this is the modern CCD device. Let's move on to importance of CCD sensors. Important and improvements of CCD sensors. Sensors improvement is basically making smaller and more effective, which improves the image quality and faster processing speeds. Application of the CCD sensors in astronomy and digital cameras allowed for better image capturing in low light and high resolution images. This is the low light condition image, and this is the difference between low resolution and high resolution images. We basically see more clarity in the images in high resolution. Let's move on to next invention. The CMOS sensors, which is also known as complementary metal oxide semiconductor sensors, which is developed in 1990s. But the working principle of CMOS image sensors was conceived in the later half of 1960s, but the device was not commercialized because the microfabrication technologies was not advanced enough. But in 1990s it was advanced enough, so they started commercialize and gave huge competition to CCD. Basically, image sensors image sensors built in today digital cameras and mobile phones are mostly used either CCD or CMOS as CCD or CMOS technology. Both CCD and CMOS are semiconductor devices that serves as electronic eyes, which they both use photodiodes. They differ in terms of manufacturing process and signal readout method. Although the CCD technology was dominant at first due to the superior sensitivity and picture quality, various improvements in CMOS sensors such as low power consumption, faster readout speed, lower cost led them to surpass the CCD sensors from 2004 onwards in shipment volume. This is the CCD CMOS sensors, and this is the CMOS sensor used in cameras. This is camera where CMOS sensor is used. Let's move on to next topic. Improvements in image resolution. Introduction of megapixel sensors in early 2000 allowed for higher resolution images. Now let us know about the story of invention, how megapixel sensors are discovered or made. There were two crucial developments leading to the invention of megapixel sensors. First, George Smith and Williard Bowles from the Bell's lab invented charged coupled device. This technology is the same image sensor that is used in all digital cameras. Second was the Sony Corporation developed the first prototype digital camera called Mavica. The Mavica only actually took the electronic still image, so it is not a true digital camera, but it did produce 720,000 pixel images. A few years later, in 1986, Kodak produced the first megapixel sensors, a fingernail-sized solid-state device that capable of recording 1.4 million pixels. Previously, cameras captured on a film. With the advent of the megapixel sensors, users could record image without need of a physical medium like film, and so accessing the image became more significantly easier. With the megapixel sensor, user could quickly capture an image and share it with the others without wasting valuable time and money dealing with the dark rooms and developing films. Megapixel sensors nowadays it can resolution goes up to 2200 megapixels. Advancements in image resolution have enabled the new applications in field like medical and scientific researches to find the new innovations and mysteries of the world. This is the megapixel sensor and this is the camera that used where the megapixel sensor is used. Let's move on to the other topic. Back illuminated sensors. A back illuminated sensor is also known as backside illumination sensors. Is a type of a digital image sensor that uses a novel arrangement of the imaging elements to increase the amount of light captured and thereby improve the low light performance. The technique was used for some time in specializing roles like low light security cameras and astronomy sensors, but was complex to build and required further refinement to become widely used. Sony was the first to reduce these problems and their cost efficiently to introduce a 5 megapixel 1.75 micrometers BI CMOS sensors at general consumer prices in 2009. BI sensors, which are also known as back illuminated sensors from OmniVision Technologies, have since been used in consumer electronics from the other manufacturers as in HTC Evo 4G Android smartphones and as a major selling point for camera in Apple iPhone. The back illuminated sensors which are basically this technology is basically used to improve the low light low light capturing images. Their applications was digital cameras and smartphones to improve the low light conditions. Now we get a question: what is front side illumination? How it differs from back illuminator sensors? Back illuminator sensor is a sensor technology that differs to traditionally imaging sensors. Instead of placing the photodiodes at the bottom of the sensor, it is placed at the top, having direct contact with light. Is it better than? We get another question: is it better than front illuminated sensors? Back illuminated sensors is more sensitive than front illuminated. When CMOS cameras were first launched, it came with front illuminated sensors. Front illuminated sensor suffers from a loss of light to charge conversions. The light coming in can be lost or bounced off when it first hits the metal wiring and other layers of electronic circuitry before reaching the photodiode. Light could also be lost through not having the right angle to make it to the bottom of the well, where having the back illuminated sensors allow the light first to, to first come into contact with photodiodes and giving a better chance for, for the light that it is being exposed to be converted into charges. Basically here backside illuminated photodiode was on the top where the image is light passes directly to photodiode, which results in better quality in low light conditions. And in front side illumination, photodiode was at the bottom. Because of this reason, when the light passes through, it can be bounced off, or because of not correct angle, it may not reach the photodiode. So the clarity of the image would be more worst compared to the backside illumination. This is the iPhone 4 where back illuminated sensors were introduced in digital mobiles. Let's move on to other topics. Other invention, which is multi-layer sensor. Multi-layer sensor has a very funny story. A multi-layer image sensor that captures the true red, green, blue using stacked CCD sensor layers. This concept was subjected in 1978 Kodak patent application, but it did not result in working image sensor. The concept resurfaced as a part of April Fool's Day prank press release from dpreview.com. When the joke was released in 2000, a remarkably similar device was under development at Foveon, the which is also known as the X3 image sensor, which is multi-layered but not a CCD. The Foveon sensor was announced on dpreview.com in 2002. Foveon has announced a new and revolutionary image sensor called the X3. A traditional digital camera sensor works by capturing just one color, red, green, or blue, at each pixel location. These individual pixel pixels are then combined in software to produce a full colored pixel. The X3 is the first sensor which is capable of capturing full color for every pixel in its array. The X3 does so with a special photo sight which measures the different colors at different depths within the silicon. This was the image which, which is taken with the help of multi-layer sensors, and each pixel was recognized each color and combined it one single picture with the help of software. This is the multi-layer sensor. Let's move on to other topic. Stacked image sensors. Stacked image sensors. Until the arrival of stacked image sensors, Megapixel has always been in a dilemma to the camera manufacturers. The main problem is more megapixels slows down the sensor's readout speed, which causes the rolling shutter effect. On the other hand, to reduce the rolling shutter effect for the high-end videos, manufacturers usually kept the megapixel count to minimal, ranging from 12 to 24 megapixel. But again, those cameras used to fall short when shooting landscapes. But the stacked sensors came as a lifesaver in this case. Stacked sensors are capable of processing light with blazing fast speed even if the sensor includes the higher megapixel counts. So stacked sensors literally paved the way for high-end hybrid cameras capable of shooting both high-end and high resolution. The stack in the introduction of this image sensor, this stacked image sensor allowed us for new features like autofocus, high-speed videos, and low-speed videos, slow motion videos. This technology is nothing but the layers the image sensors and processing the circuit on top of each other. The application of stacked image sensors are in digital cameras, smartphones to improve the performance and add the new features like autofocus and etc. This is the first and basic CMOS where the photodiode was at the bottom of the circuit. This is the backside illuminated CMOS where the photodiode is on the top, direct contact with the light. This is the stacked CMOS where we have so many layers of image sensors stacked together, and we have back illuminated sensors here because the photodiode is on top. Then light falls on the photodiode, and due to the more image sensors, it can be more faster readout speed can be happen. No shattering effects can be happen. It was great invention which revolutionized the history of the industry of entertainment. Let's move on to the future of image sensors. The potential application of image sensors are in healthcare, robotics, autonomous vehicles. In robotics, it improves the safety, accuracy, and efficiency. Then, emerging technologies in image sensor developments are quantum dots, organic sensors, and 3D image sensors. The new challenges and opportunities for future image sensors are balancing the cost, reduce the size of the sensor, and improve its performance so that everyone can widely use across the world. By improving the image sensors, it can also help to find the mysteries of this universe and find how we came to existence and etc. Are there any other aliens living among us? But we still don't know. With the help of improving the more image sensors, we will get more information, which leads to new and bright futures of our world. From I would like to conclude this image history and evolution of seminar by on a note. In conclusion, the history and evolution of image sensors has been marked by a continuous effort, effort to improve image quality, increase the sensitivity to light, reduce the power consumption, and etc. From the photographic film to vacuum tubes and semiconductor-based image sensors such as CCD sensors and CMOS sensors, the technology has evolved significantly to meet the growing demands for high-quality imaging, such as to make reels in Instagrams to post images in social media, etc. For this stuff, or to remember the history of our legacy, to make a sweet memories, etc. The development of new sensor types and designs has also brought significant advancements in the medical field of image sensing. Today, image sensors are used ado- in wide range of devices, including smartphones, digital cameras, and security cameras. And technology continuously evolve rapidly and driven by the need for higher quality and more advancing images. There is more potential for exciting possibilities and improving technology and society as well. Image sensors are very useful sensors which got Nobel Prize. Thank you. Thank you for listening to my presentation.